I hope my audio is all clear to everyone. Is my audio clear to everyone before we start the session today? Anything to do with loudness or anything else? Or is the loudness level good for everyone? All right. Thank you so much for confirming. And right in front of us, we have the topic of the day. And like I said, that this is a topic where you just need to apply your concentration very well. I don't want to intimidate you that it is a very hard topic and all. There is no topic that is hard and all, but yes, this topic requires a little bit of skill development, something that we are going to do today. Okay. So, of course, without much ado, let's jump to the topic of the day. Yesterday we did linkage, and I hope you have understood everything about linkage. And those who have struggled with independent assortment, yesterday also I had suggested that you should be taking a look on Mendelian laws of inheritance, because that is where you clarify your concept of independent assortment. And in case of any problem, one should also look into what happens during the meiotic cell division, because meiotic cell division is where the homologous chromosomes separate. Meiotic cell division is the process where the gametes are produced, and the two copies of a given gene, they can be the same allele or they can be different allele, they separate from each other. So this background is required to have when we are approaching linkage. So I hope those backgrounder things you have already filled up. And linkage, I'm supposing that you have understood well, because yesterday, even after the class, I had stayed back to take your questions and hopefully clear all the questions. Again, today also I'll be staying back after the class, so that whatever question that you have on linkage mapping, I solve them, and I'll be giving you a small home assignment also to solve a couple of problems of linkage mapping, so that you never have to struggle with making of the example in linkage mapping question, because whenever you are writing a linkage mapping answer, you will be supposed to give the example, and the example is something that you cannot memorize because it is data-based example, so you cannot memorize. The only thing that you will be doing here is to basically create the example and taking care of certain things that you will never get wrong with such examples. So we are going to learn all of this and also the underlying principle of linkage mapping. Let's start. Let's forget for a moment what is linkage mapping, even though I have defined what is linkage mapping, and let's talk about what is mapping. So when you talk about mapping, so it is basically establishing a place's location or any landmark's location. So that is what mapping is all about. Let's say that if this is by and large the map of city of Delhi, if this is the map of city of Delhi, so, and if I ask you where do you think Mukherjee Nagar is located, I think you will be struggling a bit if you are not from Delhi. But if you are from Delhi, you'll be able to say, because you already know that this is the northern boundary of Delhi and this is the southern boundary of Delhi, so on. So you know that Mukherjee Nagar is in northwestern part. So you will be somewhere plotting Mukherjee Nagar here, and you will not be entirely wrong in plotting Mukherjee Nagar here, more or less. So there are first and foremost set reference points. Do you notice that you were able to tell Mukherjee Nagar is here more or less because you know that this is the northern tip of Delhi. This is the southern tip of Delhi. So that gives you a sense where is Mukherjee Nagar. Similarly, if let's say that I make the river Yamuna flow like this, so your job is all the more easier, then you can perhaps more accurately locate Mukherjee Nagar. So what I have done, I have created yet another reference point. What if I create yet another reference point that this is a metro station of Vishwavidyalaya, that is Delhi University? It is even easier to locate. So basically, what is mapping? Mapping is pointing to the location of a place, pointing to the location of an object based on certain set reference points. What do we mean by set reference points? Just remove this. And now I will ask you to plot Mukherjee Nagar. And why this page? Let's say that I give you completely blank page and then I ask you to plot Mukherjee Nagar. It will be very inaccurate question. It will be a very wrong question to ask, because wherever you plot Mukherjee Nagar, that will be the right location. Because you can always say that this is the Delhi I thought is located. Someone can make Mukherjee Nagar here, and that person will say that this is how I think Delhi map is located. Therefore, this is my Mukherjee Nagar. So the point here is that without set reference point, there is going to be no such mapping. So reference points are to be established. Now let us talk about what is linkage mapping. What do we understand by linkage mapping? And it is very simple, that if there are linked genes, okay, we assume that if they are completely linked, and yesterday we did the classification, so we assume that कि अगर वो completely linked हैं तो उनके बीच कोई भी crossing over नहीं हो रही. That is our assumption here. Now the thing is that if there is any crossing over between them, it simply means that उनके बीच थोड़ी अच्छी खासी डिस्टेंस है, therefore some crossing over is happening between them. Otherwise वो crossing over तो नहीं होता, right? And more is the amount of crossing over, greater is possibly the distance, because if two genes on a given chromosome, this is a chromosome, okay, and let's imagine that this is the centromere. If two genes are located right next to each other, right, very close, right, chances of crossing over between these two will be very, very less. Why not I make them come all the more closer, and you will understand. Let's say that these are the two genes. Can you see that? Can you still see the gap between them? Only when we are enlarging it, you can still see some gap between these two genes. Okay, so now you can see that A and B are so close together to each other, right, that there is hardly any chance of crossing over happening between them. But still, if you see, they are two different genes. Correct or not? Answer is yes, they are two different genes. And then you imagine another gene to be present here, and another gene to be present here. Okay. Now tell me, what will be the chances? What will be the chances of crossing over between A and B? Shraddha, is the presentation blurry? Is the presentation clear for everyone? Shraddha, you may have to check your network, because from my side I can see a very clean and clear presentation. So क्या होता है ना कि when okay, everyone is confirming that it is clear. So देखो क्या होता है कि when the network speed is not up to the mark, then the video feed comes either choppy or it comes as blurry. So even if I enlarge it this much, still it should be clear enough, right? So एक बार network देख लो, Shraddha, please. Now coming back to the original discussion, so we are seeing here, and very clearly so, that between A and B, there is hardly going to be any chance of recombination crossing over. But between A and C, there will still be a sizable possibility of recombination. For that matter, even between B and C, there will be good amount of recombination. How about between A and D? A lot. Between B and D? A lot. Right. Now the question is that crossing over is a cell level event. Crossing over happens at the level of a cell. How are we going to see how many crossing overs happened? There is no way to get into a cell and basically check between two different genes how crossing over has taken place. Has it taken place or not? There is no way to check this. But is there not a way to understand how much crossing over has taken place, and that is simply count the number of offsprings. First and foremost, you establish that two genes that you are studying are linked genes. What is the way to establish that two genes that you are studying are linked genes? Simple. In F2, the dihybrid cross will be showing a predominance of parental type, whereas the recombinant types will be much less in number. And this ratio that you are getting is going to be unexplainable by any of the gene interaction ratio like epistasis and all. With help of that, you will be unable to explain any of this. And generation after generation, what you are going to see that the two parental types will be predominating. Highest will be the number of the dominant parent type, less will be the number of recessive parent type, but still dominant and recessive parental type together will account for 70% of the F2 offsprings, or maybe 80 or 90% of the F2 offspring. So once you have established that these two genes that you are studying are linked genes, then all that you have to do is to either carry out a test cross or carry out a simple dihybrid cross, and then you check. Then you basically check what is the number of the recombinant offsprings. And once you have established the number of recombinant offsprings, so you will take the ratio. Let us say that total number of offsprings is basically 100 and the recombinant offsprings are 18. So it means that the recombination percentage is 18%. So it is as simple as this. And it is possible that between two genes, the recombination percentage will be maybe 26%. So where you are getting greater recombination percentage, obviously the distance between the gene will be more. And if the recombination percentage is very low, then the genes are pretty close together. When you use this principle to establish the relative location of the genes, you will be calling it linkage mapping. Simple as this. So it is pretty much like this, that let's say that I am driving at the same speed, and from point A to point B, I reach in just 1 minute's time. But from point B to point C, it is taking me 10 minutes time. And from point C to point D, it is taking me almost half an hour time. My speed is the same. So from A to B, I am taking nearly 1 minute. From B to C, I am taking 10 minutes. And from C to D, I am taking half an hour. And then if I ask you, okay, tell me, what is the distance between A and B? You will say very little distance. What is the distance between B and C? A little more distance. And what is the distance between C and D? You will say 3 times the distance of B and C. Because between B and C, you took 10 minutes, and between C and D, you took 30 minutes. You are claiming that your speed was constant. So are you getting my point? What is the logic? Same applies to recombination. Crossing over is a random event. So if it is happening more, the distance is more. If it is happening less, the distance is less, as long as you have already established that these happen to be linked genes. That is linkage mapping. It is also known as genetic mapping, to differentiate it from molecular mapping. Molecular mapping is a separate topic, and that is something that we should study when we are in biotechnology, when we have some familiarity with the techniques like RFLP, AFLP, and sequence tagged site. Then that will give us some idea how we carry out physical mapping or molecular mapping. Physical mapping and molecular mapping are one and the same term, and genetic mapping and linkage mapping are one and the same term. Okay, so once you have understood this, in the light of this, why not we see the definition now here. So linkage mapping is an exercise in which we establish the relative distance and position of linked genes by the method of establishing the recombination frequency between the linked genes. And how do we calculate the recombination frequency between linked genes? By counting the recombinants and establishing their frequency. What do we mean by frequency? Frequency is simple. Number of recombinants upon total number of offsprings. So that is frequency. Okay. So let's say that total number of offsprings is 100 and number of recombinants is 20. So what is the frequency? Frequency is 0.2. But if you want to express it in percentage terms, then what are you going to do? You are going to multiply it with 100 and then it is 20% recombination. Correct. So this is recombination frequency. How do we calculate recombination frequency? We are going to see that. So it is an exercise to establish the relative location and relative distance between linked genes by establishing the recombination frequency between these genes. This is linkage mapping, and linkage mapping is also known as genetic mapping. I just write this and then we move to the next slide. Genetic mapping. And genetic mapping is equal to linkage mapping, and physical mapping is equal to molecular mapping. Now, okay, this page is blank. Now, here we are, okay. Follow this page clearly. Four genes I have made here. One gene is A, other gene is B, third gene is P, and next gene is K. Just randomly, I have named them, okay. So crossing over here is a random event, and if the genes are far from each other, there is high probability of crossing over taking place. So between A and K, the possibility of crossing over will be the highest because there is so much of DNA between these two, and crossing over can take place any point, at any one of these points crossing over can take place, and as a result there is a very high possibility. But between A and B, it will be much lesser. Between B and P, it will be a little more, but still very less. Between A and P, slightly more. And max will be between A and K. So I hope until now it is totally clear to everyone. Any question right now, raise hand simply and I will take your question. So I'm moving further, but if you have any question coming at any point in time, you have to simply raise hand. Okay. So let me take a question and then I'll be moving forward. So Shiva has a question. Shiva, ask your question, please.
Sir, actually, I didn't understand that crossing over you marked as a random event. What is mean that?
By random, we basically mean it can take place absolutely anywhere. Crossing over can take place absolutely anywhere. Crossing over does not make discrimination whether it should take place here or take place there. So anything that is random has an equal chance of happening anywhere. But if you give it more DNA, then the chances of crossing over between these 2 points will be much more. If you give it very less DNA, so you yourself think that in this very less DNA, how much chance of crossing over is there, and in this much DNA, how much chance of crossing over is there. So do you understand random? What does it mean to be random?
Yes, sir.
Yeah. CO is crossing over. Shivani is asking what is CO, right? So एक एक करके मैं जरा question ले लेता हूँ, right? So Parikshit is asking how is the distance affecting crossing over? It should be reverse. No, not at all. कैसे होगा reverse? ठीक है? The farther they are, the higher is the possibility of any chromosome breakage happening between these two loci. So there is absolutely no chance जो reverse होना चाहिए. It can't be. ठीक है, परीक्षित? So Shiva, is your question answered?
Yes,
So
sir.
okay, so you can lower your hand and then so Lara, okay, go ahead with your question.
So, can you exactly show how the crossing over can happen between A and K with the help of diagram?
Okay, simple. I hope you understand crossing over involves breakage of DNA, correct?
Yes, sir.
So the greater is the amount of DNA, and technically speaking, it can happen anywhere. So greater is the amount of DNA. It can take place at any of these 2 points. Let me use this eraser and let me show you how DNA can break here and there will be a crossing over. Are we clear?
Yes, sir. Yes, sir.
Let's say DNA did not break here, DNA broke here. Still it is crossing over.
Yes, sir.
Even if it breaks here, still it is a crossing over. You are getting my point. So, and between A and B, how much chance of such breakages happening you see? More than between A and K or less than between A and K?
Less than.
Much less?
Yes, sir.
Yeah, so that's the logic. I hope it is clear.
Yes, sir.
Yeah. So I think Parikshit, the same answer applies to you also. Shivani, CO is crossing over Shivani. Parikshit, I hope it is clear to you. Ritika is asking, sir, will crossing over happen between one chromosome only? No, 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 no. I have not made the homologous chromosome. Crossing over will happen between homologous. तभी तो उसका allele change होगा ना. Yesterday, Ritika, you have seen that. Keshika is asking, why are we taking linkage mapping? What is the use of it? At the end of this chapter, you will get to know what is the use of it. It is very important to know which gene is located where. That way, you can map the mutations. That way, eventually, you can map the genome. Okay, the closer they are, the better are the chances of exchanging the gene. Parikshit, in crossing over, genes are never exchanged within the same chromosome. They are exchanged between the chromosomes. I hope it is clear. Vivek, can't we say that crossing over has more possibility on telomere? Not at all. बिल्कुल नहीं. Telomere is like when you are talking about telomere itself is very, very compacted. So forget telomere, forget centromere. But in other parts of the chromosomal arm, there will be crossing over. Telomere is very compacted DNA, same is centromere. But yes, the farther they are, right, but not within the telomeric region. If it is within the telomeric region, there is going to be no crossing over because it is very compacted DNA. That's the answer, Vivek. Parikshit is clear. Shivani is clear. Parikshit, yeah, he got his answer. The more the distance, the more available breakage point. Absolutely, you have put it very correctly. The more the distance, the more available breakage points will be available. Very nicely put. Yeah. Ritika is asking, this is one chromosome only in which... No, no, no. This is not one chromosome. For the sake of simplicity, I have made one chromosome. Right? I can always make another chromosome. But I am basically trying to show you कि we are talking about कहाँ बनाऊँ ये रहा ठीक है and then crossing over will be taking place ठीक है मैं इसको remove कर रहा हूँ so the farther they are समझ लो कि homolog जब भी मिलेगा तो उनके बीच crossing over की chances ज़्यादा होगी as A and K both are in one chromosome. Ritika, you are not. अच्छा, you got it. Okay. आप सारे लोग जाकर के क्रोमोसोम और मियोसिस एनसीईआरटी में पढ़ लो पहले, ठीक है. यू ऑल मतलब ये वाला क्वेश्चन जो है ना एकदम से एनसीईआरटी के लेवल को भूलने की वजह से आते हैं. प्लीज पढ़ लेना. डोंट माइंड मी सेइंग दिस. डॉक्टर्स एंड टीचर्स शुड नेवर लाई. सो एक बार एनसीईआरटी में बैठ करके पूरी मियोसिस और पूरी जो है क्रॉसिंग ओवर एक बार देख लो सो दैट इट इज वंस एंड फॉर ऑल दोज बेसिक्स आर क्लियर. ओके, लेट मी आस्क क्वेश्चन टू सृष्टि. यस सृष्टि, गो अहेड.
You asked for the distance directly proportional to distance between genes.
Yeah.
Can you please explain this point?
Same, the more the distance, the greater is the chance of crossing over because the more breaking points will be available.
Okay.
Does it make sense? जो परीक्षित ने भी बोला था कि द ग्रेटर इज द डिस्टेंस, द ग्रेटर इज द अमाउंट ऑफ डीएनए अवेलेबल, जहाँ पे ब्रेकिंग पॉइंट विल बी अवेलेबल। यहाँ भी ब्रेक हो सकता था, यहाँ भी ब्रेक हो सकता था, यहाँ भी ब्रेक हो सकता था, यहाँ भी, यहाँ भी, यहाँ भी। आर यू गेटिंग माई पॉइंट नाउ? या, सो दैट्स व्हाट, या, ऑल राइट। चलो, नाउ मूविंग फर्दर. So this much basically you have understood. Let's put it to some more explanation, and then we will put it to some examples. So please understand that crossing over is a type of recombination event. This is an important concept which you are going to use later in this chapter as well. So crossing over is a recombination event. Okay. Distance between gene leads to more recombination event, and more is the recombination event, more will be the recombinant gametes. What is recombinant gamete? Let's say that parent had dominant A and dominant B together, and if crossing over has happened between this and this, so it is possible that recombinant gamete will be produced. Correct? Are we all clear? So this is a chromosome. All right, this is a chromosome. This is the homologue. During gamete formation, there is meiosis, and during meiosis, there is a chance of crossing over taking place. And as crossing over takes place, so what will happen? If crossing over happens, some such combination of gene alleles will be created which was not present in the parent. Now that is what? Recombinant gamete. So this is a recombinant gamete. So greater is the distance between A and B, greater is the chance of recombinant gamete being produced. And greater is the chance of recombinant gamete being produced, greater will be the chance of recombinant offspring. So when you cannot visually see recombinant gametes because gametes are themselves microscopic. Besides, within them, the chromosome will be having a specific alleles. You cannot visually examine that. But can you examine the recombinant offsprings visually? Can you see, are they representing dominant parent type, or are they resembling the recessive parent type, or are they showing one feature from dominant, one feature from recessive? And if that is so, they are recombinant. Count the recombinant, and in most of the cases, the number of recombinant is equal to the number of recombination event, and number of recombination event is directly proportionate, okay, is directly proportionate to the distance between the genes. So you count 4, and 4 is going to be proportionate to 1. So 4 is proportionate to 1. And 4 is what you can count. When the cell is dividing, you really cannot check every single cell microscopically if crossing over is happening between your two favorite genes or not. So ये आप directly तो नहीं देख सकते. Similarly, recombinant gametes you cannot directly see, but you can see recombinant offsprings when they grow up. You can see, are they like parents or are they combining both the parents' features. If they are recombinant, count them, and that 4 is going to be proportionate to 1. Is this principle clear? If it is not clear, please raise hand so that I can clarify this and then move further. I am trying to say 4 is proportionate to 1. Anyone who would like to ask? So you can raise hand. Parikshit. Difference between hybrid and recombinant. मैं अभी बता देता हूँ. देखो, recombinant within the same species होता है and within the same varieties होता है. जब हम हाइब्रिड की बात करते हैं तो या तो हम एक ही स्पीसीज की दो वेराइटीज को क्रॉस करते हैं तब हाइब्रिड बनाते हैं. कई बार हम दो क्लोजली रिलेटेड स्पीसीज को क्रॉस करते हैं तब हम उनकी हाइब्रिड बनाते हैं. एंड रेयरली इन प्लांट्स इट इज पॉसिबल टू गो फॉर इंटरजेनेरिक हाइब्रिड, दैट टू डिफरेंट जेनरा can also be crossed, and we can produce hybrid mostly by polyploidy. So when cross is between two different varieties at least, the resulting offspring will be called a hybrid. But if the cross is within the same species, same variety, only their phenotypic traits are altered, then that will be known as what? That will be known as simple offspring or simple recombinant, which is neither resembling this parent nor resembling that parent. Okay. So Parikshit, I hope this is clear. And let me take a question from Shraddha and Shiva before we move further. Shraddha, go ahead.
So, can you repeat what you told about the number of crossing events?
Number of?
You just said something about the number of crossing over events taking place. Can you repeat that for me?
I was basically saying that greater is the distance between the genes, more will be recombination event. But this you cannot see by microscope, correct? So you only presume कि अच्छा recombination हो गई. That will produce recombinant gametes, which has non-parental combination of gene alleles. But again, you cannot see it visually. But can you see the recombinant offsprings? Yes, you can see this. You count their number, and their frequency will be directly proportionate to the distance between genes. That's what I was saying.
So, sir, if there are more than two crossing events taking
If there are,
so more than two crossing over taking place within the same chromosome. So one crossing over take place another
see, I'm losing your voice, but
like the first crossing over because
I'll tell you, Shraddha. We are going to come to double crossing over thing. Let's not complicate it here. Later in this class, we are going to deal with double crossing over also. Therefore, I am saying 4 is proportionate to 1. I am not saying कि 4 is going to be equal to 1. Because in double crossing over, right, you have to apply some calculation correction. But I am not jumping there. पहले तो हम लोग इतना समझ लें कि 4 is going to be proportionate to 1. Can you agree that 4 is going to be proportionate to 1? Proportionate, not equal.
yes.
Yeah? We will come to double crossing over now when the time comes. Shiva, what's your question?
Sir, if the distance between the gene is more, the recombinant ratio will be also more.
Yes, absolutely.
Okay.
Yeah.
That's it.
Yeah. Right. So everyone can lower the hands now, and then we move further. Okay. So basically, by counting 4, you can calculate 2. What is 2? Recombination event. So when you count 4, that is recombinant offspring, you can calculate recombination events. So if there is single crossing over between A and B, so that means 4 is equal to 2. जितने recombinant offspring उतनी crossing over हुई होगी. Agreed? Right? So if there is a single crossing over between these two, so as many recombinant offspring, let's say that there are 10 recombinant offspring, so recombination is also number of recombination, number of crossing over is also 10 if we are considering case of single crossing over. All of you are clear about it? If there is a doubt, you will raise hand. Okay, chalo. Now let's consider a second case. There are 3 genes, P, Q, R. Okay. Now, रुको मुझे ऐसे बनाने दो. P, Q, R. Okay. Now let's say that I am seeing This is the parental genotype, okay? And the other parental gamete will be PQR. All right. Now let's see that we are seeing this case. This is something that we see in a particular offspring. This is something, so which is unlike either this parent or this parental combination. Now, if I ask you about two gene markers, if I ask you about two gene markers, that is P and R, right? I ask you that do you see between P and R any recombination? You will see no. P is dominant, R is dominant. So between P and R, there seems to have no recombination, no crossing over that has taken place. But look a little closely. Between P and R, Q has changed. Between P and R, can you see Q has changed? So to change Q between P and R, do you understand that you will have to apply two cuts? Otherwise, how will you change between P and R a single gene? So without applying two cuts on the DNA, you cannot shuffle Q. So even though on the surface ऐसा लगता है कि between P and R there is no recombination, but here there are two recombinations which have taken place, right? So this is called double crossing over. To change the gene allelic combination, if two crossing over events have taken place, we call it double crossing over. So in cases of double crossing over, the number of recombinant offsprings is not true representative of number of crossing overs which have taken place. You will need to multiply it with 2. Then you will be getting the number of recombination events. Else you will not be getting the correct number of recombination events. So इसको मैं erase करता हूँ and we are going to see with examples. So by counting 4, what is 4? The number of recombinant offsprings. You please calculate 2. That is the number of recombination events. Mostly 4 is equal to 2. What does it mean? That when there is single crossing over, number of recombinant offspring is equal to the number of crossing over. But in double crossovers, number of recombinant offsprings multiplied by 2 is going to give you the number of crossing overs. And we are going to see very soon. So 2 is proportionate to 1 and 4 is proportionate to 2. So they all are proportionate. Okay. So this is called Sturtevant's formula. Now, where does this name come from? Sturtevant, right? So the story goes back to the days of Thomas Hunt Morgan. So Alfred Sturtevant was a student in T.H. Morgan's lab, a master's student. In America, we call it graduate student because undergraduate student is someone जिसको हम यहाँ पे ग्रेजुएट स्टूडेंट कहते हैं, वहाँ पे हम अंडरग्रेड कहते हैं, और जो मास्टर्स कर रहे होते हैं उनको हम कहते हैं ग्रेजुएट स्टूडेंट. सो एल्फ्रेड स्टर्टवेंट was a graduate student associated with T.H. Morgan's lab. And Morgan, he had already clearly and correctly explained what is linkage. So Morgan ने ये correctly और clearly explain कर दिया था. But Morgan was unable to basically find a relation कि कुछ जीन्स के बीच में काफ़ी लिंकेज हम देखते हैं, कुछ जीन्स के बीच में हम काफ़ी कम लिंकेज देखते हैं. ऐसा क्यों है? This problem he did discussed with his lab mates and all of that, including Alfred Sturtevant. So Alfred Sturtevant, it is said that he worked for almost 24 hours continuously. And he could basically establish a correlation that the genes between whom a lot of recombinants are being produced are actually far located from each other. This was his hypothesis. And the genes which are closely located, उनके बीच crossing over कम होगी. And as a result, what is happening? कि उनके बीच recombinant offsprings कम दिखेंगे. So that is something Alfred Sturtevant worked about. And then Alfred Sturtevant used this hypothesis to develop a method by which, by counting the recombinant frequency, we arrive at recombination frequency, and then whatever is the recombination frequency, we assign those many map unit to gene distance. But remember, map unit is not the SI unit of distance. That is, SI unit of distance is going to be meter or the multiples of meter or divisibles of meter. But we are not talking about meter. He created a separate unit called map unit. He said that if two genes are located apart from each other by one map unit, it simply means that there will be 1% chance of recombinant offsprings being formed between them. And if two genes are located 20 map units away, that will mean that there are 20% chances of seeing recombinant between them. So इसको रिवर्स में ले लो कि 20% recombination means 20 map unit distance, 1% recombination, then 1 map unit distance. So that is a Sturtevant formula which lies at the foundation of linkage mapping exercise. Let me take Shraddha's question and then I will move further. Shraddha, please go ahead. I have unmuted you from my side.
Sir, am I audible?
Yes, you are.
So the concept that you just explained of double crossing over and the relation, मतलब जो proportion वाला concept है वो समझ नहीं.
नहीं देखो, let me simply show this to you कि I'm giving you 3 gene loci, okay? I'm giving you 3 gene loci और आप ऐसे देखो, give me a moment please. Sorry. So I'm giving you 3 gene loci. One is A, second is B, third is C. If I give you a problem that keep A and C the same, but between them change the allele of B. Basically, I am asking you to get me this. What do you think, at how many places the chromosome will have to break? You can type in the chat box. How many places the chromosome will have to break? Two places? Okay. 2 places. So now, yes, correct, Pragya. Chesta is also correct. Now, despite this, there will be a single offspring which will show this type of recombination. Despite this, there is going to be a single offspring which will be showing this type of recombination where A and C represent one parent type, but B is representing the other parent type. But this single offspring is product of what? Two crossing over events. Every chromosomal breaking is considered to be one crossing over event. So this one offspring is product of what? Is product of two crossover events. And because this one offspring is product of two crossover event, so to get the variable number 2 was what? Recombination event. Recombination event. So what are you going to do? Recombination event को count करने के लिए अब recombinant offspring को 2 से मल्टीप्लाई करना होगा because each such offspring is product of two crossing overs. Did you understand this? And did everyone understand this? Simply in the chat box you can write. Or if there is still a question, you can raise hand. Shraddha, is it clear to you? How will we know that there is a double crossing over? Don't worry, we will be knowing when we are checking the phenotype. जब टेंटेटिव मैप बना लेंगे तो वो भी पता चल जाएगा. Don't worry. All right. चलो पता चल जाएगा कि कहां पे डबल क्रॉसिंग ओवर हुई है. So you have now understood who was Alfred Sturtevant, and Alfred Sturtevant was the person who could establish a correlation between the distance between gene, recombination events, and recombinant offsprings. Okay, and he said that by counting 4, calculate 2. Mostly 4 is going to be equal to 2, but sometimes number of offspring को 2 से multiply करना होगा if there is a double crossing over. And that 2 is going to be directly proportionate to the distance between gene. And he also said that whatever the percentage recombination will take place, those many map unit, I will consider the distance. And map unit is not a physical unit, it is a genetic unit. Okay. Now, basic ideas. So we have learnt it yesterday. Okay. अब बस इसको organized text में same चीज repeat हो रही है. Crossing over results in recombination. It breaks up the association of genes that are close together on the same chromosome. Linkage and crossing over can be seen as processes which have opposite effect. सीख लिया है. Linkage keeps particular genes together and crossing over mixes them up. Frequency of crossing over between two linked genes is mostly directly proportionate to the distance between genes. This much we know. Okay. So this is also something जो हमने कल ही देखा था. मैंने बस इसलिए ला दिया कि मान लो कि इनके बीच कोई क्रॉसिंग ओवर नहीं होती तो सारे गैमीट पेरेंटल टाइप के बनेंगे. कंपेयर द पेरेंटल क्रोमोसोम, डोमिनेंट ए, डोमिनेंट बी, रेसेसिव ए, रेसेसिव बी. सारे गैमिट्स को देख लो, डोमिनेंट ए, डोमिनेंट बी, रेसेसिव ए, रेसेसिव बी. बट इफ क्रॉसिंग ओवर टेक्स प्लेस, then you will see some non-parental gametes also. Dominant E, dominant B is there, but then dominant A and recessive B are there, which is non-parental. Recessive A, dominant B is there, which is also non-parental, right? And then recessive A and B are anyway parental. So if crossing over takes place, non-parental gametes will be forming. And if non-parental gametes are forming, in that case, what is happening? In that case, what you see is non-parental offsprings, जिनको हम recombinant offspring कहते हैं. Now we come to recombination frequency, right? So first and foremost, you calculate recombinant frequency. Who is a recombinant and what is recombination? This is an important term. So recombinant is an offspring produced by recombination. Okay. And what is recombination, by the way? Recombination is what? Recombination is the process of creating non-parental gametes. All right. So recombinant frequency is what? Recombinant frequency is number of recombinant progeny upon the total number of progeny multiplied by 100. So that is the percentage. Okay. So I have put it here also. पता नहीं मैंने नीचे वाले को क्यों इग्नोर कर दिया. So product of recombination, and recombination is crossing over for our purposes. आगे हम देखेंगे कि there are other types of recombination also, something that we are going to see tomorrow. Okay, tomorrow we are focusing on recombination and crossing over only. So in normal crossover product, right, recombinant frequency is equal to recombination frequency. And in double crossover products, recombinant frequency multiplied by 2 is recombination frequency. Right? So when you are calculating the gene distance, don't rely on recombinant frequency, get the recombination frequency. And it is a very good question that was put to me a little while back by Laraib. I hope I'm pronouncing your name correctly. It may be Laraib also. So, but whatever it is, please pardon me if I mispronounced it. So, how will we know there is a double crossing over? We are going to see that. But remember that recombination frequency is something which you have to rely upon while establishing the gene distance and not recombinant frequency. So get the recombination frequency from recombinant frequency. So let's call it RT and let's call recombination as RN. RN is recombination and RT is recombinant. Okay. So normal crossing over, RT is equal to RN frequency. Okay. And अगर डबल क्रॉसिंग ओवर होगी तो RT frequency multiplied by 2 is RN frequency. Correct. So that's how it plays out. Time to calculate. Okay. This is the experiment where Betson and Punnett discovered linkage. You can pull out your calculators also. If you want, mobile calculator you can very well use, or we will calculate it together. Okay. So purple flower and long pollen, red flower and round pollen. Now self-fertilization, first generation, all purple flower and long pollen. F2 generation. Now let's do some calculation. We are trying to establish the total number of offspring. So 284, 21, 21, 55. This is the number of offsprings. Am I correct? Or am I missing anything? No, I think I'm correct. Okay. So this is the number of offsprings. Now out of these, 42 offsprings are recombinant and 381 is the total number of offsprings. Multiply it with 100. And whatever the number that you get, right, whatever the number that you get, it is going to be slightly above 12% or something, right? So just a guess looking at the numbers. So it is around 12% or so. It can be 12 point something or so. So that is something, or it could be a little less than 11.02. ठीक है ना? So correct कर ही देता हूँ. ये देखते ही हो गया था या कुछ कैलकुलेटर वगैरह भी लगाया है? अगर देखते ही हो गया था तो इट इज वेरी इंप्रेसिव, और कैलकुलेटर लगाया है तो इट्स ओके. calculator, no worries. So we are having this. So स्टेटमेंट ने कहा कि अगर ये रिकॉम्बिनेशन फ्रीक्वेंसी है तो हम कहेंगे कि डिस्टेंस इज गोइंग टू बी 11.02 मैप यूनिट, और दूसरा भी यूनिट था 11.02 centimorgan. Centimorgan in the honor of Thomas Hunt Morgan. So it was defined like this: 1 Morgan is 100 map unit, and centimorgan is 1 map unit. So 11.2 map unit is 02 map unit is 11.02 centimorgan. Simple as this. So did you understand this thing easily? If there are two genes which are linked, so how are we going to establish the distance? You will carry out a normal cross or a test cross, and in test cross direct result उसमें आप proportion गिन लोगे, and in normal cross you will have to wait until F2. But whatever it is, the proportion of recombinant in contrast to the total number of offspring expressed in percentage term is the map unit distance between the two genes. Right? This is called 2-point test cross. It is performed for two loci at a time to establish the distance between them. मतलब दो जीन्स को आप कंसिडर कर रहे हो एक टाइम में, ठीक है? दो जीन्स को एक टाइम में कंसिडर कर रहे हो. ये अगला प्रॉब्लम लो, और इसमें मैं क्या करता हूं कि इसको हटा दिया, जो फाइनल कैलकुलेशन था वो हटा दिया. राइट. सो यहां पे श्रद्धा इज आस्किंग, इज दिस रिकॉम्बिनेशन फ्रीक्वेंसी और रिकॉम्बिनेंट फ्रीक्वेंसी? श्रद्धा, बिकॉज दो ही जीन को कंसिडर कर रहे हैं ना, सो देर इज गोइंग टू बी अ सिंगल क्रॉसओवर बिटवीन two genes. There is going to be single crossover. When you take 3 genes, then there arises a chance of double crossover for the gene that is in between. So here, because there is a single crossing over, so you have got recombinant frequency is equal to recombination frequency. But when there are 3 genes, you will have to look for double crossing over. Is it clear? Vidyadhar is asking, sir, please use less Hindi. Vidyadhar, don't feel insecure about me using Hindi. If there is anything I'm using in Hindi, I'm necessarily translating it. So come out of your FOMO and let me speak how I speak. But as a responsible teacher, I will not let you miss a single word of mine. If I utter a single word in Hindi, it is going to be translated. Okay? 8 map units. Absolutely. 8 map unit. Correct. Vasavi is asking, but the frequency must be proportional to the distance. Okay. Proportional hai to the physical distance. But when we have adopted map unit, so how are we defining map unit? Vasavi, hear this carefully. Map unit is defined as the distance between gene that gives rise to 1% recombination. So when we have that thing, can we use them as equal if we define map unit like this? Yes or no? I am going to show 2-point test cross. 8 map unit, 8%, 8 centimorgan, 8 map unit. Everyone got it correct. Correct? Okay, nice. Very nice. But more people should have answered this. Less people have answered it. Okay? So this is the opening slide, Srishti. This is the opening slide for 2-point test cross. Performed at 2 loci, means 2 different genes at the same time, at a time to establish the distance between them. So these are 2. One determines the color of the eye, one determines the length of the body. So 2 strains of Drosophila were mated. An initial study on linkage happened a lot on Drosophila. So you cannot give good example of linkage without mentioning Drosophila. So there are certain disciplines which transcend the boundaries of botany, zoology, and all. Like zoology student, howsoever they want, when you're talking about Mendelism, you are going to talk about garden peas. When you're talking about linkage, botany students will have to talk about Drosophila. When you're talking about sex determination, most of your example are going to come from the animal world because that is where sex determination has been studied. So on and so forth. Okay. So in Drosophila, let's see. So this is a test cross. So heterozygous, which has one dominant, one recessive for both the genes, is mated with what? Homozygous recessive. That is what? Classic test cross. Then you get all the four types. Okay. And then you see that total 1,000 offsprings are there. All right. And out of them, 80 are what? 80 are recombinant. So 0.08 multiplied by 100 is 8% recombination frequency. Why recombination frequency and recombinant frequency is being used interchangeably here? Because it is a case of single crossover, and single crossover recombinant frequency is equal to recombination frequency. Shraddha is asking percentage value is converted into map unit, right? Absolutely right. As long as it is single crossover product. If not, we will be adjusting the calculations. One more, solve on your own. Here you have the numbers. It is okay. Now you have the numbers. Calculate on your own and tell me what does it look like. I will just tell you that these two are parental ones. These two are parental and these are recombinants. '18 map unit. Wonderful. 18 centimorgan or 18 map unit. Perfect. Perfect. Now you all have become professional geneticists. So here you have the answer. 820 are parental, 180 are recombinant. The total number of offspring is 1,000. 180 happen to be recombinant. So 18% recombination frequency, hence 18 map unit. Clear? Okay. So this is 2-point test cross. As easy as it gets. 3-point test cross is what I was referring to. Okay, 3-point test cross is what I was referring to, which will require a little bit of your concentration. Here we go. Recombination mapping with a 3-point test cross. What does it mean? It operates like 3 sets of 2-point test crosses. Sounds a little hard, but it is actually not. Okay, so let me give you a hypothetical example. I'm not using India specific example, otherwise you will be quickly telling the distance and correct order. Let's use an overseas example, hoping that perhaps you are not aware of their respective locations. Okay, so let's say that I decide to drive from New York City to Washington, D.C. Okay. And someone tells me, okay, someone tells me that pretty close by is the city of Philadelphia. So, so why not you visit these places also, because DC and Philadelphia are not very far from each other. So if you are going to DC, you should be seeing Philadelphia. I said, why not? I will do that. So in the US, the distances are normally expressed in miles. Okay. So it so happens that NYC to DC is about 280 miles. But to my pleasant surprise, DC to Philadelphia is merely 80 miles. So that's so nice for me. And then I am given the data that NYC to Philadelphia is 200 miles. There are 3 points on this: A, B, and C. Can you tell me which city is A, which city is B, which city is C? Answer this as fast as you can. Okay? Yeah. So first full answer has a lot of full answers have come. But let me start with a little wrong answer. Okay? So, Pragya, if NYC is city C, how does it justify the data? Let's say that I put NYC as city C. So, what is going to be my city B? Pragya, what is my city B? चैट में बताओ. अच्छा चलो अनम्यूट करता हूँ, बताओ.
Yes, sir. I actually in jaldi likh diya. What distance between NYC and DC is 280. So it is clear that the both are at the one end. One is on NYC and another is on DC. So in between B is matlab this Philadelphia.
So C,
NYC might be.
no. So C is NYC or DC?
I think because the DC has given DC and Philadelphia has 80-meter distance. So
80 miles. हाँ, 80 miles. हाँ, so what does C look
it will
like?
be C looks like DC.
DC.
एक मिनट sir.
ये बायो नहीं है, ये सी सेट है. अब बताओ.
Sir, I am just doing. I am telling you, कि NYC and DC has the 280-meter distance, 120 miles, and whatever it is.
Mm-hmm.
Then it comes out like they both are at other ends.
Correct.
Each other.
Correct.
In between, we has to fit Philadelphia, which is 200 miles distance from the NYC. So and 80 miles distance from the Philadelphia. So sir, I am just doing that. So I just wrote
अरे listen, अब सुनो मेरी बात. Right. Let's say that NYC and DC have the farthest distance. So there are only two chances. Okay. Either A is NYC, in that case, C is DC. Okay. Or C is NYC and A is DC. यही दो chances है ना, और तो कोई तीसरा chance नहीं है. But here comes B, that is Philadelphia. Philadelphia is merely 80 miles from DC. So now you tell me, does this distance look like 80 miles or does this distance look like 80 miles?
No, sir. Another distance between DC and Philadelphia is already given 80 miles, so it doesn't
Yeah.
look like.
It does not look like, so it means C is DC, right?
That's why earlier I said,
Hmm.
oh, I got wrong. In
Yes.
speed and I just got sent.
नो 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 नो, एग्जामिनर को कोई फर्क नहीं पड़ता है स्पीड से, उसको करेक्टनेस चाहिए.
हाँ.
ठीक है,
Okay, sir. Thank you.
राइट. सो आई होप यू गेट इट. I hope you get it nice and you get it well. So A is NYC, B is Philadelphia और C जो है वॉशिंगटन DC है. Let me see कितने लोगों ने गलत किया था. देखो एक और गलत आया हुआ है माज से. माज आपने A को NYC लिखा जो कि ठीक था, B को DC लिखा, C को फिलाडेल्फिया लिखा. तो अगर सी फिलाडेल्फिया होता है तो एनवाईसी और फिलाडेल्फिया के बीच के 200 माइल के डिस्टेंस को कैसे आप रिकंसाइल करोगे? आप बताओ माज, क्या सी कभी फिलाडेल्फिया हो सकता है? हो ही नहीं सकता. शिवा इज राइटिंग बी इज फिलाडेल्फिया. श्रद्धा हैज रिटन एनवाईसी फिलाडेल्फिया एंड डीसी करेक्ट. बी हैज टू बी फिलाडेल्फिया, जावा रोट. NYC is A, Srishti wrote, okay. So basically it is NYC, B is Philadelphia, Priyanshu ने लिखा था, and C is DC. Most of you got it right, most of you got it correct. ठीक है, चलो. अब एक बात बताओ, अब मैं थोड़ा साइंस पे आता हूँ. अगर मैं इसमें से एक डेटा को हटा देता हूं, कैन यू मेक दिस मैप? यस, नो. एक डेटा को हटा दिया मैंने, एनवाईसी और फिलाडेल्फिया के डिस्टेंस को हटा दिया. नाउ टेल मी, कैन यू मेक दिस मैप करेक्टली? प्रियांशु नो, सूरज नो. More people. Can you make this map correctly? Vivek, no. Ritika, there are two possibilities. Yes. So correct answer तो नहीं पहुंचोगे ना. Java, you can't make it. Yes is not the answer. No, yeah, there are two possibilities. So we can't determine the position. Yes. So you got it. कि to have one final answer, you have to have these three data. Then you can actually make. Then one sec. Then you can actually make the correct map. Otherwise, you won't be able to make the correct map. There will always be two possibilities, and yes, there will be two possibilities. There will be two possibilities. We can't determine the position. Two possibilities. Insufficient data. Absolutely right, Shiva. So, tell me. कि if these are not three cities, okay, if these are not three cities and we are talking about three genes, correct? If these are not three cities and if these are three genes, so what will be the data based on which we can establish their relative distance? Only one. Tell me, between A and B, what is the recombination frequency? Tell me, between A and C, what is the recombination frequency? And tell me, between B and C, what is the recombination frequency? If you do not have all the three set of data, you are not going to solve this thing, that what is the relative distance and what is the relative position of A, B and C. करेक्ट. सो मैंने क्या लिखा था, अब इस लाइन पे वापस आ जाओ. It operates like 3 sets of 2-point test crosses. Means if I am giving you to solve the distance and position of 3 genes A, B, C, so you can solve it only if you have got AB recombination data, AC recombination data, and BC recombination data. That is the only way to solve. So let's try and solve it. Now, all of you, please wake up. अगर अभी तक कम भी attention दे रहे थे, तो please do wake up. Now the serious work starts. Okay? Here we are. So, in the examination, all of you, full attention. Unfortunately, some people left the class a little early, so that is too bad. And some people have not turned up. That is even worse, because this is one class where you needed to interact with me real time. Chalo, ab pay attention, all of you, okay? Don't write anything, I'm gonna share this, okay? So by tomorrow morning you will have it, but please pay attention. Let's take 3 different genes, okay? And understand my tricks and techniques simultaneously. Okay, so these tricks and techniques will help you a lot. From now, next 20 minutes are very crucial. So I am taking 3 genes. Let's call them D, E, F. ये 3 genes मैंने लिए. Okay, let me change the color. मैंने 3 genes लिए D, D, E, F. Okay. Why did I not take A, B, C? That's the first question. When you take A, B, and C, from exam point of view, it is not a great name for the genes. Why? Recessive allele of A is very clear. Recessive allele of B is very clear. Recessive allele of C differs from its dominant only by size. So if it differs only by size, in the examination, you cannot always maintain that consistency. So forget A, B, and C. When you talk about D, E, F, so you know that its recessive allele will not only differ in size, it will also be differing in shape. And it is very easy for the examiner to see if you mean dominant allele or if you mean recessive allele. So my favorites would be P, Q, R, because all of them are differing in shape. So let's start with D, E, F. Okay. So first and foremost, step by step, we, one sec. What happened? Give me a moment. So first and foremost, we set up a test cross. Okay. So test cross is D, E, F, D, E, F. That is what? That is one parent, and this is homozygous recessive DEF, DEF. So you get what? Heterozygote. So this is parents. This is F1. So parents are pure breeding. Cross. So this is our step 1. Obtain F1. So we have gotten F1. And if in F1 we see सबका phenotype is like the dominant parent, right? सबका phenotype is like dominant parent, and then what we do is to perform a test cross. So step 2 is perform a test cross. Deliberately, I'm slow so that you can absorb everything. Try not writing, but if you feel that you want to write it, so it is up to you, but understanding it more primary here. So when you perform the test cross, so basically what you do, so you do this. उसके बाद क्या होगा? उसके बाद ये ट्राई हाइब्रिड है. सो ट्राई हाइब्रिड में 8 डिफरेंट कैटेगरीज ऑफ फिनोटाइप विल बी सीन. डाई हाइब्रिड टेस्ट क्रॉस में कितने डिफरेंट फिनोटाइप आपको दिखे थे? डाई हाइब्रिड टेस्ट क्रॉस में 4 डिफरेंट फिनोटाइप दिखे थे. और अगर क्रॉसिंग ओवर नहीं हो रही होती तो 2 डिफरेंट फिनोटाइप दिखते. हैड देयर बीन नो क्रॉसिंग ओवर, देन इन ड्राई हाइब्रिड क्रॉस, dihybrid cross, you would have seen only 2 phenotype had there been zero crossing over. But we are talking about genes between whom crossing over is happening. So in dihybrid, there will be basically 4 phenotype, and in trihybrid there will be basically 8 phenotype. Okay, so there are 8 phenotypes. The formula is 2 to the power n, where n is number of loci. For how many loci you are performing the cross? So 2 to the power n, and n is here what? N is 3, so 8 different phenotypes. Okay, and Pragya is writing 4. But Pragya, what you have given me is independent assortment. We are talking about linked genes. So for 9331, you are not going to see predominance of parental type, much reduction of recombinant types. Okay. So Rahul, yes, you got it correct. There are 3 loci. So basically, we have performed already 2 operations. First operation that we performed was what? Obtain the F1 generation. Second operation, what did we perform? That perform test cross. Correct. So these 2 steps we have already done. Step 3 is what? Step 3 is tabulating the 8 phenotypes and giving them number. This number is based on certain principles. So we are now going to follow those principles. So third step is making table of test cross progeny. Okay, there are 8 phenotypes minded. So here we are. This is most important. This is where most people get it wrong. So this is a part where you need to get it right. Now, we are going to create 8 rows. So 3 rows, 4, 5, 6. Are we there yet? 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now, this is their category. This is their number. And in between, you are going to have what? In between, you are going to have their tentative genotype. So, like this. One second. This is parent type 1. This is parent type 2. This is recombinant 1, recombinant 2, recombinant 3, recombinant 4, recombinant 5, and recombinant 6. Parent types are going to predominate. Okay. So please understand that if there are 8 phenotypes, so out of them only 2 can be parent type. Rest of them are going to be recombinant. So there are 6 recombinant categories. Now, if you are now talking about parent type, so parent types are going to predominate. Okay. So let's give the 2 parent types certain numbers. Did you notice in the previous 2 crosses, the total number of offsprings were 1000? So was it a coincidence? No. It was a way to put the data which finally comes to such a figure with which you can easily divide your offspring number, right? So therefore 1000 was the number. Here also we are going to put it 1000. Take a look here. So out of 1000, one of मैंने पहले ही डिसाइड कर लिया कि 800 is what I am going to give to the 800 is what I am going to give to whom? 800 is to the parental type, and other 200 I am going to give to the recombinants. Here we go. So if I have got 800, so 2 parental type, I am not going to give them 400 and 400. I am going to give 1 parental type more, 1 parental type less. So let's say that one is 440, right? One is 360. So together they have got what? Together they have got 800. Now we have to divide the remaining 200 in 6 categories. Okay. Whenever we are talking about the recombinants, so we are going to talk about this type of recombination between D and E, where D is dominant and E is recessive, या फिर हम बात करने जा रहे हैं D और E की ऐसी वाली recombination. You are getting my point? But ultimately it is recombination between D and E. चाहे हम इसकी बात करें or we talk about this, but ultimately it is recombination between D and E. Therefore, whatever the number of this one is, let's say that its number is 30, this number is also going to be close to 30. It is possible that this can be 32, this can be 28, but the number is going to be largely comparable. So first and foremost, let's give these parental types their genotype. So here our genes are D, E, F. So to show the dominant character, you need to have this genotype. It really doesn't matter what was the other allele of D as long as you had one dominant copy of D. Same applies to E and F. But to show the recessive parent type, you must have this genotype. Are we sorted here? Clear, all of us? Any doubt to anyone? Raise hand before I put it something else on this table. Okay, so I'm assuming that until now we are clear. Shiva, tell me your question.
So I'm not understanding the parental type 2.
Parental type 2 is the recessive parent. So that's it.
Okay.
Yeah.
Okay.
Right. Okay. So can we write P1 genotype like this in the examination? Of course. I'm giving you exactly what you are supposed to write. Otherwise, P1 genotype, you will have to create all the combinations, which is totally unnecessary. Right? Sir, P1 homozygous dominant nahi hoga? No. How do you know the genotype? As a field geneticist, you can only see the dominant phenotype. You can't go and see the dominant allele. Okay. Rightmost column is the number of offspring, absolutely the number of offspring. All right. ठीक है, इतने ही क्वेश्चन थे. Now, in this what we are going to do, okay, in this what we are going to do, that we are going to keep two genes in one parental type, but the third gene we are going to change. ठीक है, the third gene we are going to change to the other parental type. Let's say D, let's say that D is like dominant parent phenotypically, because see, a geneticist can only count the phenotype. You can't examine every one's genotype. So D is dominant, E is dominant, F is what? Recessive. So it is a recombinant or not? Answer is yes, it is recombinant. And its counterpart recombinant will be where D is recessive, E is recessive, but F is dominant. So that means D and E being one parent type, F was like other parent type. Now their number is going to be highly similar, nearly equal. Their number is going to be highly similar or nearly equal. So now 200 is the number that we have got. We have to divide them among 6 offsprings. So, and these 6 can be divided into 3 sets. This is F being other parent type, while D and E were one parent type. So let's give them 60. Let's give them 70. And let's give it 70. Okay. But in real world, that doesn't happen. In real world, what happens? That 2 of them will be having higher share and one will be having a little smaller share. So what we are going to do here, that we are going to give this one 80. Okay. We are going to give this one 85 and we are going to give this one only 35. And this could be anyone. You can give this one 80 and you can bring this one at 35, or you can bring this one at 35. Which one is showing 35? Eventually this one will show up as double crossing over. You just wait and see. So one sec, let me just clear. So we have decided on the numbers 85, 85, 85, 80 and 30. So let's say that we are giving it 85. Okay. Next one we will give 80. Last one we will give 35. Or maybe the next one we will give 35. Last one we will give 80. Now 85 we have to give here. And we have to divide it nearly equally. So it can be 42 and 43. That makes it 85. Or what you can do to make it more realistic kinds, you can basically make it 41 and 44. That is pretty okay. Now moving next, we are changing E. We have changed F now. We are now going to change E. D will remain dominant, F will remain dominant, E will become recessive. And in the next one, D will be recessive, F will be recessive, E will be dominant. Like this. D is dominant, F is dominant, E is recessive. And its opposite is D recessive, E dominant, and F is recessive. I have decided to give this one 35. So 18 and 17. Last one is going to get 80. And in this one, so we have already played with what? F. Here these two were one parent type, but F was flipping. These are recessive, F flipped to dominant. Here E has flipped. Next is the turn of D. So D is dominant when, okay, no, D is recessive when E is dominant, F is dominant. And D is dominant when E is recessive, F is recessive. The number is what? 80. Like a kid, we can divide it into 40-40. Like grown-ups, we can do it 38-42. So it looks very real data. You put 000 nice 0, it looks childish data. In fact, I would actually want to change these numbers also. The total will still be 800. But if you see, so now this looks authentic lab data that सीधा lab से उठ के आ रहे हो, ठीक है? Total will be 1000 because this one is 800, this one is 85, 885, this one is 35. So what does it make? 885 and 35. So that is 920 and this is 80, so 1000. So total number of offspring is 1000. The choice of genotype is difficult to comprehend. No, it is not difficult. See, only thing is keep two genes as dominant parent type and flip the third gene. Do the opposite. Keep two as recessive, flip the other as dominant. Is it clear, Parikshit? And can you do it for the rest three genes? Yes or no? है ना? Because if you label it as difficult, in the exam you are not going to attempt it. So I don't want anyone to spend 2 hours in this class and still not attempt this one, right? So it is simple. Keep any two dominant parent type and third one will be recessive and do the opposite. This one is dominant while other two are recessive. हो गया recombinant. Okay. Now let me copy this table because we are going to use it on many pages. So what we have done? We have made a table for test cross progeny. Vivek Singh, this is what we used to do with the number of data. Array, that you should not have done in the lab. So Vivek Singh, this is what we used to do. Give me a moment, Vivek. So see what Vivek has written. Is it the right thing to do? But yes, right. Shubhalakshmi, go ahead and ask your question. Ask your question.
Sir, am I audible?
Yes, you are.
Sir, we are doing the test cross so that we can get the sufficient data to plot the result.
Yeah, you had two choices. Either you do test cross or you simply carry out F1 selfing. But ratio numbers will change, ratio will remain the same. Okay. Pragya, what's your question?
Sir, actually, I didn't understand that basic thing कि why, मतलब ratio is same, but why numbers are varying, मतलब like in 85, 41 is and 44.
Because of their distance, because they are not equally they are not equidistant, na? Their distance might be different. So as the distance is, so will be their recombination frequency.
Sir, another, in 85 number, that in between 41 44, alleles are the opposites, sir. मेरे कहने का मतलब है कि जैसे कि लिंकेज इज द मतलब डिस्टेंस का फंक्शन होता है
Absolutely. Yes. हाँ.
जो मतलब पर्टिकुलरली जो भी जीन लिंकेज पे क्रॉसिंग ओवर हो रहा है जिनका,
हम्म.
कि रिकॉम्बिनेंट 1 और रिकॉम्बिनेंट 2 में उनके नंबर्स 41 और 44 है, व्हाई दे आर नॉट इक्वल, मतलब
See, if you have got a very high amount of offsprings, very high number of offsprings, it will be very close. I'll give you one example and you will understand. Let us say that I flip a coin only 10 times. Right? I flip a coin only 10 times. Is it not likely that I can get even 7 heads and 3 tails? Or maybe 6 heads and 4 tails? So it will be 60% head and 40% tail. But what if I flip the coin 1,000 times? It will be very close. Right? So that's what.
Okay, sir.
Yeah. Shraddha, what's your question?
Now, why did you say that for R1, for example, for R1 and R2, the numbers will be almost similar, and same for R3 and R4, R5 and R6. I mean to say for dominant T and recessive F, and then recessive dominant for the same. Why numbers are similar?
Numbers are similar because these are the same genes, different allele, na? So if the same genes, so then their distance will be the same. So ultimately अगर आप देखो, right, तो यहाँ पे D और यहाँ पे D और E के कंपैरिजन में F ही तो रिकॉम्बाइन कर रहा है. आर यू गेटिंग माई पॉइंट? जीन तो नहीं बदला ना, तो जीन की डिस्टेंस भी तो वही होगी ना, जो भी हो. अभी हमने एस्टेब्लिश करना है, तो जो भी डिस्टेंस है, तो इनके बीच का जो रिकॉम्बिनेशन होगा वो तो नंबर सिमिलर ही होगा ना. यू गॉट इट श्रद्धा? वो डोमिनेंट हो या रेसेसिव हो, लोकस तो वही रहेगा ना. आर यू गेटिंग इट श्रद्धा? और इज देयर समथिंग अनक्लियर? If there is some audio issue, you can simply put it in the chat box. Okay, now let us, now it is clear. Okay, now let us, we are very close to conclude this topic, maybe another 10 minutes. Copy it. Fourth step is calculating recombinant frequency for ड्राफ्ट मैप. देखो, रिकॉम्बिनेंट के फ्रीक्वेंसी से यू कैन मेक ड्राफ्ट मैप, और रिकॉम्बिनेशन की फ्रीक्वेंसी से यू विल बी मेकिंग फाइनल मैप. बट आई टेल यू व्हाट हैपेंस. चलो, नाउ हियर यू हैव टू अप्लाई द सेम प्रिंसिपल. Means you have to break it into 3 recombination event: recombination between D and E, recombination between E and F, and recombination between D and F. So first one is recombinant. RT is recombinant between D and E. Second is RT between D and F. Third is RT between E and F. Okay, calculate करते हैं इसको थोड़ा. Let's identify the recombinants between D and E carefully. Okay, so here the identity will be D should be dominant, then E will be recessive, or D is recessive, then E will be dominant. That is the recognition, nothing else. Okay, so let's take a look. Is this one a recombinant between D and E? Is this one a recombinant? No. Why not? D is dominant and E is dominant. Right? Is this one recombinant? No. Because D is recessive, E is recessive. So they are like parent. But is this one recombinant? R3? Yes, D is dominant, E is recessive. Of course, R4 will be there, D is recessive, E is dominant. R5? Yes, D is recessive, E is dominant. R6, D is dominant, E is recessive. So basically R3, R4, R5 and R6. R3 plus R4 plus R5 plus R6. So the total number is 18 plus 17 plus 38 plus 42 is 105. And frequency of recombinants, FRT is frequency of recombinants, is 105 upon 1000. And percentage will be what? 10.5%. Correct? So it is 115. Yes, my mistake. It is 115. Thanks for correcting me. Otherwise, we would not have gotten the right answer. That's what. Vasvi, why should it be divided by 800? No. Total number of offspring is what? Total number of offspring is 1000. 800 parental type, 200 recombinants. So that's the total number, Vasvi. Is it clear? Now recombinants between D and F. So that will be R1. अब आप लोग टेबल को खुद से देखो. And if R1 is there, R2 is also going to be there. Then R3, no. R4, no. R5 and R6 will be there. R5 plus R6 will be there. That will mean is equal to 120. And therefore, percentage of recombinants is 12%. Are we correct? You got the number 12%. It is like 41, 44. That is what? 85. And R5 and R6. Sorry, my mistake. Again, big mistake. 85 and 80, 165. So it is 16.5. 16.5, yes. Correct. So 165. Now E and F. Between E and F, which one we calculate? E and F R1. Also R2, obviously. R3, yes. Of course, R4. But no R5 and no R6. So basically what we are looking at, 85 plus 35, this is 120. And that means percentage of recombinants is 12%. Correct? So what is the highest distance? What is the highest distance? Highest distance is between D and F. ठीक है? So ये तो बिल्कुल alphabetically ही हो गया. Highest distance is between D and F. And then E is somewhere between them. Correct? Let's see it. So fifth step is draft map preparation for establishing gene order. Why do you need to establish the gene order? Because until and unless you establish gene order, you will not be able to check the double crossing over. So gene order is like max distance is between D and F. देख रहे हो ना? Max distance is between D and F, 16.5. And E is a tiny bit closer to D compared to F, because here it is 11.5, here it is 12. So D and F are far apart, and E, rather than being at exactly in the middle, it is slightly closer. Yes, slightly closer to E. But mind it, still there is no matching of the numbers. Why? Because this is 11.5, this is 12, this is 16.5. Right. So the numbers are right now not matching, but they will match. Don't worry. Now what we have understood, that we had not calculated D and F properly, because when we were calculating D and F, last very intricate point, when we were calculating D and F, did we include these types? या did we include this type जब हम D और F के बीच recombination count कर रहे थे? Answer is no. Why not? Because then we were not knowing the gene order. Why we were not doing the gene order? Because we had not yet solved it, right? So we were not knowing the gene order. Fact is कि we should be including these two categories also in our calculation for D and F recombinants. And not only that, because it is a proper double crossover, so we need to multiply this number with 2, and then we need to bring it here. So what you are going to do here? You are going to recalculate the recombinants between D and F. Okay? Now sixth step is recalculate recombinant frequency by recombinant frequency between D and F by including double crossover products. Means the offsprings which are products of double crossing over, they should also be included. Okay? All right. So D and E, how does it become 15 centimeter? Nowhere it is 15 centimeter. Centimorgan, right? It is 11.5 D and E here. Shraddha. So now we are going to recalculate. सो DNF, सो अभी तक हमने DNF में किसको किसको ऐड किया था? R1, which is obviously, R2, which is obviously, but we had not included these two, right? We had not included these two because it looked to us that when D is dominant, F is dominant, when D is recessive, F is recessive. But the fact is, because E is the middle gene and E cannot change until two breaking has taken place. To change E between D and F, you need to cut chromosome at two places. How do you know this now? So in the beginning there was a question, how will we recognize double crossing over? Only by establishing the gene order based on a draft map. So now that we have a draft map, so we are going to recalculate it like this. So we are going to recalculate it like R1, R2, R5, R6, R2 and R3 and R4 we are going to multiply it by 2. So it is going to be like this. R1 plus R2 plus R5 plus R6 plus, okay, plus why? Because we are now including the double crossovers. So this we already know that R1, R2, R5 and R6, they together make 165 plus this one is, इसको सॉल्व करते हो तो 35 होता है, ठीक है? So that is 165 plus 70. What is that? 235. Correct. Now 235, that will mean percentage will be 23.5%. So now you will make a final map. And do you see the numbers are now adding up? Seventh and last step. Preparing a final map with, अब आपका डिस्टेंस भी करेक्ट हो गया. पहले वो टेंटेटिव डिस्टेंस था विच विल गिव यू अ सेंस ऑफ जीन ऑर्डर बट नथिंग एल्स विद करेक्ट डिस्टेंस. नाउ you have got this, and now what you have got here is 23.5. Now are the numbers adding up? Answer is absolutely, the numbers are adding up. So that's the beauty, that we picked up totally fictitious data and still the numbers added up. So this is the linkage mapping. So Chesta is asking, this means it will only happen with middle gene? Of course. Only to change the middle gene you need two cuts. The one that is on the margin, a single cut will change it. Is it clear? So today you absorb only this much. Now its merits, demerits, I will explain tomorrow. Because tomorrow the theme is going to be, it's a small topic. Tomorrow I'll keep it easy. Tomorrow it is going to be simply crossing over. And I will start the class with a discussion on merits, demerits of linkage mapping and all. But this much if you have understood, right? Vasu is asking, we are multiplied by 2 since there are 2 cuts. Yes. Shiva is asking, explains once the 6th step. Simple. We included the double crossover, and earlier we have established the principle that we will multiply it, so we did that. Larib is asking, should we mug up the table? You can't mug up. Right? Slight ambiguity, no. I'm confused at sixth. Hold on, sixth. Take a look here. DNF. R1, R2, R5, R6. We had calculated already. So R1, R2, R5, R6. How much we had calculated? 165. That 165. Now we are adding these two also, R3, R4. Why we are adding? Because this is double crossover. Correct? R3 and R4 we added double crossover. Earlier we have seen that if there is double crossover, we have to multiply it by 2. We did that. So 35 into 2, 70. So 160 plus 70, 235. That gives you 223.5. Is it clear, Kajal? Is it clear, Shiva? And there can be no ambiguity. Today, I was telling you that this is the home assignment. And home assignment is what? Home assignment is simple. That go and make one similar. How to find DOC? Arey Shiva, you find DOC by establishing the gene order here. When you establish the gene order, you are not paying attention enough. What is written here? Draft map you prepare to establish the gene order. So if D, E, F is the gene order, so if D and E, F are same and this E has changed, do you not think that this is a case of double crossing over? That's how you identify. Sixth step, why aren't we dividing? What else we are dividing with? 235, how did we make 23.5? What did we divide it with, Vasvi? 235 is 23.5% by dividing with what? Sir, we prepared draft map to identify the middle gene. Absolutely. This is the reason why you always have to prepare a draft map. With this calculation, can we locate a gene exactly? Not exactly, relatively. With respect to D, where is E? That much you can locate. If you want to know exactly molecular mapping, that's what. All right. Please repeat the trick to write different recombinants possible. Simple. Repeating it again, pay attention. Keep two genes in parental type 1, third gene opposite. Then keep two genes as parental type 2, third gene opposite. Repeat it for all the three genes. That's how you will do it. Like DE like dominant, F like recessive. DE like recessive, F like dominant. DF like dominant, E like recessive. Now DF like recessive, E like dominant. Last, EF like dominant, D like recessive. D dominant, EF recessive. That's how we pick. Okay. So now what I would say that based on this, you prepare another table. You have to get it right at your practice level before you can put it in the examination. Right. You have to get it right. Once you do it, once, twice, it will be forever yours. If I'm not having to explain this, I can repeat all the steps in 10 minutes flat, including the calculations. If I don't have to explain, if I am silently doing it, you put a timer and 10 minutes flat, I will be doing this. So you can also do this. It is only about understanding the concept. And don't try to leave it, because if you try to leave it even at slight difficulty, then half of the syllabus you will end up leaving in every subject. एंड जीएस में पता नहीं कितना ही चीजें लीव कर दोगे. Yes, to deal with double cross, we have to deal with trihybrid cross. Of course, because between two genes, A and B, a single break will change. Anywhere it takes, but a single break will change. Right? So, all right, then, I think that is enough for today.